So when working on problem number 25, we saw a problem that reads, suppose that x, y, and z are positive real numbers such that 1 over x plus 1 over y plus 1 over z equals 3, x plus y plus z equals 5, and y times z equals 10. Then the largest possible value of x can be written in the form p plus square root of q for integers p, q, and r, where q is not divisible by the square of any prime number. Compute p plus q plus r. So generally with problems that give us a lot of variables and a lot of equations involving those variables, I tend to start from the first equation given, get as much information from that equation as I can, and then move on to the later ones as I work. So to start with, I'd want to look at the equation 1x plus 1y plus 1z equals 3. Now you should notice that we can rewrite this as a sum of fractions with the same denominator. If we were to rewrite it, we're going to see something that looks like this over here, where yz over xyz plus xz over xyz plus xy over xyz equals 3. That's what we get if we find the common denominator for fractions with the denominators of x, y, and z. And once we've got them all into the same denominator, we can go ahead and combine it into a single fraction with the sum in the numerator, which is what we're going to get right here. xy plus xz plus yz over xyz equals 3. Now, we could simplify it a little bit further, but before I do that, what I'm going to notice is that I have a term of yz right here, and I have x times a term of yz right here. And I know from the problem statement that y times z is equal to 10. So what I can do is I can take the y times z values here and substitute them for 10. And that way I'll be getting rid of some of my variables, which you can see we did right here, giving us xy plus xz plus 10 over 10 times x equals 3. And now what we can do is manipulate this equation a little bit further. I always like to get rid of my denominators whenever I have a fraction, especially a fraction with a variable in the denominator. So multiplying both sides by 10x is going to give us the equation xy plus xz plus 10 equals 30x. And if we take these two terms right here and we factor an x out of them, we're going to get x times y plus z plus 10 equals 30x. Now, y plus z, we don't have a statement for that in the problem statement the way that we did for y times z, but we do have as our second equation, x plus y plus z equals 5. And if we manipulate that second equation, we can get that y plus z equals 5 minus x. So telling us the sum of y and z in terms of x. And we should notice that if we substitute 5 minus x for y plus z, we're going to have an equation with only x as the variable, which is good for us because we want to solve for the largest possible value of x. That's what we're searching for in the problem statement. So getting rid of the values of y and z is going to make that a lot easier. So by making that substitution, we end up with this equation right here. X times 5 minus x plus 10 equals 30 times x. And if we expand this, this parenthetical multiplication right here, we're going to get 5x minus x squared plus 10 equals 30x. Or if we reorder things so that all of the variables are on one side of the expression, we're going to end up with x squared plus 25x minus 10 equals 0. And that is a stereotypical quadratic equation. So what can we do with the quadratic equation? Well, we can put in our values for a, b, and c into the quadratic formula. And you might notice that the quadratic formula is a rational number plus a square root divided by another rational number. So if we plug in the values, we have 1 for a, we have 25 for b, and we have negative 10 for c. we're going to get that x equals negative b, so negative 25, plus or minus b squared, so 25 squared, plus, well, it would be minus 4 times a times c, so 4 times 1 times negative 10, or just plus 4 times 1 times 10, over 2 times a, which is 1. And simplifying the addition and multiplication that we have here, we end up with x equals negative 25 plus or minus the square root of 665 over 2. And we could be done here, but we can also notice that since we're looking for the largest possible value of x, that we would want as many things as possible to be positive. Because if this is negative 25 minus the square root of 665, that's definitely going to be a negative number. But if it's negative 25 plus the square root of 665, well, 25 squared is 625. So the square root of 665 is going to be a little bit more than 25. So our final result, when we add the square root of 665 to negative 25, is going to be positive. So it'll be the larger result. So we can just say that this is negative 25 plus the square root of 665 divided by 2. And all of a sudden, we have our p, q, and r values in this expression here. And we get that p equals negative 25, q equals 665, and r equals 2. So adding them together, we get negative 25 plus 665 plus 2 equals 642, which is answer A in our choices, and we're done.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.